You are welcome to chemistry class once again with an Christopher GK, your teacher. Of course, it has been a wonderful class in the previous video. This particular video, we are going to consider a topic very important in chemistry, and the topic is aromatic hydrocarbons. But once again, before we continue, I would like you to just go straight to my YouTube channel and just hit the subscription button by subscribing to this particular channel, so that whenever I upload my videos, you will be able to have the notification for that. Hit the subscription button and also notification button, and you are good to go. All right, today we have a topic in chemistry, very important, called aromatic hydrocarbon. Aromatic hydrocarbon is expected that by the end of this particular video, you should be able to explain what aromatic hydrocarbons are. You should be able to explain what they are. Then number two, you should be able to list at least 5 examples of benzene compounds or derivatives, or give 5 examples of aromatic hydrocarbons. It's one of the things we want to achieve by the end of this class. Another one is you should be able to explain the method of preparing benzene. By the end of this video, you should know how benzenes are being prepared. Then next one, you should be able to state the properties of benzene, properties in terms of physical properties and chemical properties. Lastly, you should be able to even list the uses of benzene. These are the things we want to achieve by the end of this particular video. So we are going to follow them one after the other by first of all looking at what actually is benzene. All right, what is benzene altogether? Whenever you hear about aromatic hydrocarbon, benzene should strike to your mind. You can't talk aromatic hydrocarbon without benzene. Benzene is aromatic hydrocarbon. Still remember that hydrocarbons are being classified into 2: aliphatic hydrocarbon and aromatic hydrocarbon. We have been discussing in previous videos about aliphatic hydrocarbon that has to do with alkanes and alkynes and alkanes. These are the aliphatic hydrocarbons which you have discussed. Now the next part of it now is aromatic hydrocarbon, which we want to discuss now. And benzene, we say that when you hear about aromatic hydrocarbon, think benzene. Think hydrocarbon, aromatic hydrocarbons, think benzene. Benzene is the aromatic source, is the source of aromatic hydrocarbon. So that is why I put benzene as a topic we are going to look into, because that is the aromatic hydrocarbon and other derivatives are from benzene. All right. Now benzene, the most common aromatic hydrocarbon, as I said, is benzene, which the formula is C6H6. Now, the benzene structure, benzene contains 6 carbon atoms in the ring and the 6 hydrogen atoms. And the structure looks like this. It's the common way of representing benzene by representing it in this hexagonal shape. Hexagon in the sense is 6 carbon atoms, and it has 6 hydrogen atoms also. And the 6 carbon atoms are being represented in a way that they have 3 double bonds and 3 single bonds, each alternating to each other. That means double bond, single bond, double bond, single bond, double bond, single bond. So that is how it's being represented. No clearly. It can be represented in this way. The first one with showing the double bond and all the hydrogen bonds in the compound. Or you can use hexagon as a plane shape, as a shape like this, putting all the bonds at the respective place, and double bond and single bond without putting the hydrogen bonds being placed. Now, that one, it shows that at the extreme of any shape, at the end of each of the points, is where carbon is. Carbon is located at the edge of each particular point, and it can be represented in either way. Now, because of the alternating movement of the double bond and single bond, it means that where the double bond is, it can change position to come down to where single bond is, and single bond can move up to where double bond is. So that means it delocalizes, it moves down the circle or the shape of the hexagonal shape of benzene. Because of that, the best way, the main structure to represent benzene is by drawing the hexagon and inscribe circle in it. That is the last shape by the right. Writing it that way eases you. It is easier, it is perfect that way, because some persons can write the shape, but how to place the double bond becomes a problem. So the best way to do that is to write the hexagon, draw the hexagon and put circle inside. Inscribe circle inside the shape, and it gives you benzene structure. That is the perfect way to draw it. All right, that is for benzene, the structure of benzene, and how the bonds are being placed. Now, in 1945, the concept of resonance was used to explain the structure of benzene, which I just talked about now. The ring structure of benzene is represented as a regular hexagon with an inscribed circle, indicating that the double bonds are shifting at all times. I've talked about this. The rings also shows that the 6 electrons involved in the double bonds are moving around the 6 carbon atoms in benzene. So the best way, easiest way to represent benzene is this way, and we call it resonance structure because of the alternating movement of the double bond and the single bond around the benzene structure. So we have this as a structure of benzene. Anybody, any chemist, any scientist that sees this, you know that this is benzene structure, and it gives you a straightaway structure of benzene. And the formula still remains C6H6. All right, let's now look at the other examples of aromatic hydrocarbons. And I still said before, the aromatic hydrocarbons, other ones are the benzene derivative structures that we will get from benzene. We can't get any aromatic hydrocarbon without benzene structure, first of all. So we have something like nitrobenzene. We can see that nitro is being substituted on benzene structure, nitrobenzene. We have ethylbenzene, we have bromobenzene, we have toluene, which is a methylbenzene, we have phenol, which is hydroxybenzene, we have aniline, which we have also anasol, which is a methoxybenzene. So these are, we have many of them. We have anthracene, we have many compounds of it. So these are just examples. We know we targeted at least 5. We should be able to name other benzene structures on this. All right, so these are the examples, few examples of benzene that we can give now. Then, how can we now prepare benzene? How can we prepare benzene? One of the structures, one of the ways to prepare benzene is by cyclic polymerization. Remember, when we are talking about alkene, the last video we talked about in alkyne, we said that alkyne, which is ethyne, undergoes polymerization. When 3 ethyne polymerizes, when ethyne polymerizes, that means 3 ethyne comes together, it will form benzene. And how does it do so? By cyclic polymerization. Look at the structure. Alkyne, which is ethyne in the alkyne group, has 2 carbon atoms with triple bonds. Look at when it changes and combines together, bonds together, 3 of them joins together, the bonds will change location, just like the diagram given below. So benzene is prepared from ethyne by the process called what? Cyclic polymerization. In this process, ethyne is passed through a red hot iron tube at around 873 Kelvin. The ethyne molecule then undergoes cyclic polymerization to form benzene. And when he does that, you have this structure of benzene. 3 ethyne. Ethyne, the formula of ethyne is C2H2 times 3 will give you benzene structure, and it can be represented this way. All right, that is it. We can prepare it also. This is another structure for that. We can also prepare it from another aromatic compound, which is aromatic acid, benzoic acid. Now, benzene can be prepared from aromatic acid through decarboxylation reaction. Remember the first one, we use cyclic polymerization. Second one, we use decarboxylation reaction. In this process, sodium salt of the benzoic acid, which is sodium benzoate, is still a derivative of benzene, which is a benzene compound, is heated with soda lime to produce benzene alongside sodium carbonate. Soda lime is mixture of sodium hydroxide and calcium oxide. But the equation will represent sodium hydroxide because it's the active reagent on it. And the sodium carbonate will be produced alongside benzene as a structure. So this is one of the ways in which we prepare benzene. All right, another one, we can also prepare it from phenol. Phenol is a aromatic hydrocarbon also. It's a derivative of benzene. When we are giving an example, we cited it before. Phenol is just hydroxy benzene, that is phenol. In this process, vapors of benzene, of hydroxy benzene, which is phenol, are passed over heated zinc dust. Then the zinc dust reduces them to form benzene. As you can see in the structure, that zinc is being allowed to pass over the phenol, and it reduces the phenol to benzene, and the structure is being given below. So we have discussed that one of the ways in which you can prepare it by what? Cyclic polymerization. Number 2, decarboxylation. Number 3, by using zinc to reduce phenol, and we'll have benzene. So these are the methods in which you can use to get benzene prepared. All right, what are the physical properties of benzene? Properties of benzene, we discuss the physical properties and chemical properties. Chemical properties has to do with the reactions of benzene, but let's look at the physical properties first. Benzene is a colorless liquid with a sweet smell. In fact, virtually all the aromatic unsaturated hydrocarbons, double bonded and the triple bonded hydrocarbons, have some level of sweet smell. So benzene is a colorless liquid with a sweet smell. Number 2 is that it's insoluble in water. It has a boiling point of 80 degrees Celsius, meaning that it has lower boiling point than water. All right, what are the chemical properties, which are very, very important to the topic benzene? Now, why are they important? They are important because we need to understand the chemical behavior of any particular substance. So in benzene has some attributes and chemical aspect of it. Number 1 is that it undergoes substitution reaction. When undergoes substitution reaction, this particular type of reaction is very, very important. Listen. Of course, other unsaturated hydrocarbons are known for addition reaction. Of course, benzene still undergo addition reaction, but substitution reaction is key to this because of the delocalization of the bonds, double bonds of benzene, unlike other ones that localizes. Now, here, through the substitution reaction, we have different benzene derivatives that we have. We do have both for phenol, methylbenzene, methoxybenzene, and all of that, ethylbenzene, and many of the compounds that we do have through substitution reaction, they can be produced. Now, benzene undergoes substitution reaction. When benzene undergoes substitution reaction with chlorine, it undergoes it with so many elements and compounds. Now, when he undergoes that with chlorine, we're going to have this. We'll have chlorobenzene. That is the name. We have chlorobenzene. Of course, hydrogen chloride will also be gas, will also be evolved, will also be given out, but this is the major product and it's of our concern. All right, that is number 1, substitution reaction. Number 2 is addition reaction. Very, very important, and we know that whenever unsaturated hydrocarbon undergoes addition reaction, the end product should be alkanes. Will be alkane. Alkane will be the end product. So benzene also undergoes addition reaction. He undergoes that when he undergoes hydrogenation in the presence of nickel catalyst, the three molecules of hydrogen, most of hydrogen molecule will attack the double bonds in the benzene structure, and it will turn to cyclohexane, which is an alkane compound. It will turn to cyclohexane. So cyclohexane is formed when a mixture of benzene vapor and hydrogen are passed over a nickel catalyst. It's just about hydrogenation of benzene gives you this. All right. Okay, we are going to look at this again by looking at the uses of benzene. Two peculiar chemical properties of benzene. We discussed it: substitution reaction and addition reaction. What can we use benzene for? Benzene, number one, is that it can be used as solvent. We also use it as an intermediate material for the production of rubber. We can use it as fuel. We can use it in printing industry. So benzene can be used in all these places, and there is very, very useful in industry. That is it. So far, we have discussed about benzene, what it takes, the structure of benzene, the examples of benzene derivatives, which are the compounds of aromatic hydrocarbon compounds. We have talked about how to prepare benzene. We have talked about the physical and chemical properties of benzene. Then uses have also been discussed. And we said that the common compound of aromatic hydrocarbon is benzene with the structure C6H6. Benzene structure, we said that it consists of 6 carbon atom and 6 hydrogen atom alternating. The double bond is been alternating through the double bond and single bond. And the ray structure of benzene is represented by a hexagon, regular hexagon, with an inscribed circle, indicating that the double bonds are shifting at all the time, at all times. All right, the ring also shows that the 6 electrons involved in the double bonds are moving around the 6 carbon atoms in benzene. That is what we have done, and I have talked about the behaviors and chemical properties and all of that. So that is it. But before we end this video, I have to give you some assignment and assessment you need to do and try what we have done so far in previous exams that we've done in WAEC. Number one, we are going to look at benzene consists 6 carbon atoms and 6 hydrogen atoms. A, draw 2 stable structures of benzene to show how these atoms are arranged. Of course, we talked about it. II says, what is the concept behind this structure? What is the concept behind these structures? B, give 2 uses of benzene, 1 industrial source of benzene. WAEC 1990, number 7. Number 2 question says, name the process of obtaining benzene from ethane. I call the name of the process. So WAEC 1994, number 4. These are the little assessment that I've given to you that you need to do in respect to this particular video. Thank you for being part of this video, and still remember, for further discussion and inquiry, do well to get me through my phone line, +234 80 655 73229, +234 80 655 73229, or send me an email or any further thing to my email address through my email at cristo116@gmail.com. Still remember, do well to subscribe to my channel by hitting the subscription button and also notification button bell. Do that, and you get notification whenever I upload a new video. Thank you for being part of this particular class, and remain blessed. Thank you so much.